Hello everyone, welcome to the TheGeoecolologist. I am Dr. Krishnanand and you have been watching my series on physical geography. So in this session on oceanography, we are going to learn about the Atlantic Ocean's bottom relief topography. So let's discuss, but before we go ahead, don't forget to subscribe to our channel and do share the videos with others as well. So now let's learn about Atlantic Ocean, its ocean bottom topography. So in the earlier lecture, in the introduction, we also learned about the basic physiography of the ocean. Now specifically to Atlantic Ocean, let's learn about it. So Atlantic Ocean basically is what? It's a body of salt water, as we know, and it covers 1/5 of the Earth's surface. That is important in terms of its area or size, and separating the continents of Europe and Africa to the east from those of North and South America to the west, that we know as in the world map. And it is second in size to the Pacific Ocean. So remember, Pacific is the largest and second largest is the Atlantic Ocean, right? Now let's understand how this Atlantic Ocean gets its name from. So it comes from Greek mythology, basically meaning that it is a Sea of Atlas, right? This is important to remember. And from Latin or from Greek, the word is Atlantikos, that is from Atlas or Atlant. The term originally referred to as Atlas Mountains in North Africa. Remember, this is the Atlas Mountain in the North Africa. Here is the Morocco. Here you have Strait of Gibraltar, right? So this is one place where you have this Atlantic Ocean. So this is just adjoining to the Atlas Mountain. So that is how the connection is, that this was just the sea near this particular Atlas Mountain, and later on it was referred to as the Atlantic Ocean on the same basis. So in the histories of Herodotus, if you see around 450 before Common Era, he writes what? Atlantis Thalassa. So remember, Sea of Atlantis was basically, remember Panthalassa, Pangaea. So it is Atlantis Thalassa, which is the name, or the Atlantis Sea. So that is basically referring to the Atlas, who's supposed to be the Greek god, right? Who's holding the entire world on his shoulders, right? So where the name refers to the sea beyond the Pillars of Hercules. Now these Straits of Gibraltar, this place, Pillars of Hercules, this place is beyond this. So this area is called the Sea of Atlantis, which is said to be part of the sea that surrounds all land. That's why the word is Atlantis Thalassa, remember? And that is where the Panthalassa word also came when we talked about the theory related to the entire ocean origin and Earth's origin, right? So Pangaea, Panthalassa. So that is what we talked in the continental drift theory as well, right? Under the evidences. So this is about the basics of the word Atlantic itself and its location, its area, its size. Now let's elaborate further more. So if you look into the history again, the term Ethiopian Ocean was derived from ancient Ethiopia and was applied to the southern part of this Atlantic. Now remember, the southern part of Atlantic was also called Ethiopian Ocean until mid of 19th century, right? During the age of discovery, remember, from 14th to 16th century, if you see, the Atlantic was also known to English cartographers. And by what name? By the name of Great Western Ocean. So this is important to remember. It was considered as Great Western Ocean because it was west of the England. And the pond is another name which is also very famously used by British and American speakers in context to the Northern Atlantic Ocean specifically, which is narrow, and that's why sarcastically many times people refer to as just as a pond by undermining or making an understatement, which is also called meiosis. So that is another important word that is used in context to Atlantic Ocean only. So this is regarding the concept of the word Atlantic and also how it has been named, and Northern and Southern Atlantic have been known to the geographers, cartographers and other scholars by different names at different particular time period. So this Ethiopian Ocean in 1710, this French map of Africa, and here you see this is the ocean and this is the southern part which is called Ethiopian Ocean. So this is to be remembered here. Now the first factor there is shape and size. So if you observe this shape, it's largely like a S, right? So it is also sometimes referred to as the S-shaped ocean because of this particular feature, and it occupies an area of about 82 million kilometers square, which is about 1/6 of the total area of the world, or 1/2 of extent of the Pacific Ocean almost. Remember that. And shape of the ocean is rather unusual in the form of the letter S, and indicating what? The continents on either side were once part of the same single landmass. So remember, if you have knowledge of this jigsaw fit puzzle, so this particular feature is fitted here, this feature is fitted here. So once this was part of the same landmass, as we know, and that is what we have learned through the theory of the continental drift and underplate tectonics, right? So the average depth, if you see in this particular area, is about 3,300 meters, and maximum depth is 27,493 feet, which is about 8,380 meters. And where is it? It is at the Puerto Rico Trench. At this particular location, you see this Puerto Rico Trench here. This is what is this particular area in north of the island of Puerto Rico, which is about the deepest part of this ocean. Now, ocean's breadth factor from east to west varies considerably. So remember, from east to west, every place, because it is a sigmoid or it is a S-shaped ocean, you see there is a difference, right? Not everywhere is the same length if you observe. So what is here? Newfoundland and Ireland area. This is Newfoundland and Ireland area. This particular area is the shortest that you see, right? So it is about 3,320 kilometers. And farther south, it widens to more than 3,000 miles. That is about 4,800 kilometers before narrowing again. So you see, first it is narrow, then it becomes wide, then again it becomes narrow at this particular portion near the equator, and again down south it again gets broadened. So this is like narrow, broad structure. So this is how it happens, right? And southward again, when it becomes broader, it is bordered by simple coasts almost without islands, and between Cape Horn and Cape of Good Hope, if you see, where is Cape Horn and Cape of Good Hope? If you observe this particular area, remember this is the Cape Horn and this is Cape of Good Hope. So this is what we say between the South America and Africa. This particular distance is the widest, and that is about 6,500 kilometers wide. Right? So remember, the least and the most, this is what we need to remember. So least is this 2,850 kilometer, and where is it? It is between this particular area in Brazil and in Liberia, right? So this is Cape Palomas in Liberia, and this is Cape São Roque in Brazil. So this is Cape Palomas, and this is particular area in Brazil. So this is the shortest distance, right? And this is the farthest distance. So remember these two areas, one is 2,850 and one is 6,500. So this is how the width is distributed. So this is all about the shape and size. Now let's look at the other features. Now talking about the origin and development of this ocean. So the origin and development of Atlantic Ocean are now accounted by the theories of continental drift, as we know, and also later on plate tectonics that we have already learned under geomorphology. So if you have not watched the videos on continental drift and plate tectonics, you can go to the playlist on my channel in geomorphology segment and you can watch the videos in detail. So what happened? The vast proto-continent, remember Pangaea. So this was a vast continent which was together, and it started separating about 175 million years ago, and that is when this separation started happening. So plates moved sidewise, and what happened? This ocean was formed in between. So this ocean was formed when these plates started moving the other way, right? So this is what we talk about it. And what are the evidences? We have geological and paleontological evidences. It means the formation of these particular mountains on the sides or the rocks and all those minerals that are found. Apart from that, the fossils that are found on both the coasts, right? Or they are of the same origin. So that is important to understand in terms of evidences that we have already learned in the continental drift theory. And perhaps the most conclusive evidence that is bearing out of this history is the origin is to be found in existence of mid-Atlantic ridge. Now remember, in this middle segment, this mid-Atlantic ridge is the best thing that we can understand as an evidence that this ridge formation is due to the material which is coming from the upper mantle to the crust, and that is what is being deposited as a ridge line. So it means that material is coming out, so this material is actually going away, and in between there is a void created which is now filled by the material or magma coming out. So this is the best evidence for this particular theory that we say, that is continental drift and plate tectonics theory. Then going to the bottom relief of Atlantic Ocean, the first feature, as we have already learned in the previous lecture, is the continental shelf. So let's understand about continental shelf of in particular ocean, right? So barring few areas, the Atlantic is largely characterized by having a broad continental shelf. Remember, the entire area has broad continental shelf from north to south. Some areas are not there because those are the plateau margins in certain parts. So they don't have a shelf area, but largely it has a greater shelf area. So the Labrador coast, you see, 240 to 400 kilometers. Now remember, where is Labrador coast? So the northern portion, this Labrador portion, remember, this is having the largest broader shelf. Then if you see the Brazilian coast, it is very narrow. Now this is the narrower portion. You don't have a shelf area if you look into this image particularly, right? Then excepting the east coast of the southern part of South America, where Falkland Islands are found on the continental shelf, the South Atlantic Ocean is generally narrow. So remember, apart from this southern part, there is Falkland Plateau. Mostly you will find, because it is an entire plateau area which is there on the edge, so you don't have an extension of the shelf. So that is important to remember. While the coastal areas of Africa and Brazil being plateaus. So remember, the coastal areas of Africa and Brazil are mostly plateau areas, and that's why you don't have a larger shelf, right? So here in north and here in south you have a bigger shelf, but mostly in this particular middle belt you don't have a huge shelf in the bottom relief that we understand. Now looking at this particular next feature, that is slope feature, so continental slope. So passive margin slopes of the South Atlantic Ocean are widest. Now remember, there is something called active margin and passive margin. What is a passive margin and what is an active margin? Remember, where the subduction is happening, that margin is called the active margin, because the activity is going on here, the material is going down, magma is being converted, right? So all these things are happening, activities are happening here. While the other margin, where there is no subduction happening, right, that margin is called passive margin. So we are talking here about the passive margin slopes in South Atlantic. Remember, southern part of Atlantic, which are widest on average, if you observe, that is about 73 kilometers of slope. And although slope attains great width where of 368 kilometers in North Atlantic, where the slope protrudes south of Newfoundland. Now remember the Newfoundland area, right, where you have 368 kilometers of this slope. So now let's learn about this huge feature, or the most unique feature of this ocean, which is Mid-Atlantic Ridge, or is also known as Mid-Oceanic Ridge, or MAR for the short form, right? So where is it located? This is what is the Mid-Atlantic Ridge portion, right? So this line, if you observe, this is the middle line, right, of this Atlantic Ocean, and a divergent constructive plate boundary. Now remember, it is a divergent boundary which is like this. So this plate, South American plate, is diverging, African plate is diverging, and in between this ridge is created from the material that is coming out from the mantle that we have already learnt about it. And this is one of the longest mountain chains in the world, as we know, right, from about 14 to 15,000 kilometers long, and average is about 4,000 meters high. So that is important to remember. And in Northern Atlantic specifically, now remember, this is the Northern Atlantic Ocean, right? So Northern Atlantic Ocean, it separates North American from Eurasian plate. So this is North American plate and Eurasian plate. So this is a separation line here. And remember, in southern, you have South American plate and African plate, which is separated by the Southern Atlantic Ridge. Now the ridge under the Northern Atlantic Ocean was first inferred or discovered by Matthew Fontaine Maury in 1853. Remember, this was the same time during 1854 when isostasy also was being studied, right? So isostasy was being studied by Pratt and Airy in 1854, 1859. So this was the same time when this mid-oceanic ridge was also being studied. That's why Pratt's concept talks about this mid-oceanic ridges. Remember that? And the existence of this ridge and its extension into South Atlantic was confirmed during the expedition of Challenger, that is 1872. So remember, this is important to remember in this particular way. Now, apart from this, there is something which is also here to quote, is this particular triple junction. Now remember, this is a junction where this is meeting. This plate, and this plate. All three plates are meeting. So this is called a triple junction. And what is the name of this triple junction? It is called Azores triple junction. Now remember, this is Azores triple junction, which is very famous. And here is the detail. If you see, Eurasian plate, North American plate, and the microplate which is in between this is called Azores microplate, which is just here ahead of this northwestern part of the African continent. So this is what is a point to remember here, that it also has a triple junction that is part of the Mid-Atlantic Ridge. Now going further, if you see near equator, if you observe this Mid-Atlantic Ridge, it is divided from equator. Near equator you have this Romanche trench, right? So Romanche Trench is a particular place which divides this into the north or the south ridge. So this is around the equatorial region, right? So that is important to remember. And what is the depth of this trench? It is about 7,758 meters, and one of the deepest location of Atlantic Ocean. Not the deepest, but one of the deepest. Remember, the deepest is the Puerto Rico Trench, right? So that is to remember here. Now, if you look the northern part from this Romanche Trench, the northern part, this is called Dolphin Rise. Remember, it was discovered through Dolphin Expedition, and the southern part is also called Challenger Ridge because it was discovered in the Challenger Expedition. So in North Atlantic, the Mid-Atlantic Ridge is relatively wider. If you observe the Mid-Atlantic Ridge in the northern part of the Atlantic Ocean, this is wider if you observe it, right? And it forms a broad telegraph plateau, that is to remember. So here in the northern part, if you observe, this is the telegraph plateau that we need to remember, that northern Atlantic Ocean has a broad ridge which forms a plateau-like structure called telegraph plateau, and also extends from Ireland to Labrador. So this is Ireland and this is Labrador, so it extends from this particular east to west portion. So this is what to remember. And Iceland, remember this particular portion, Iceland is divided by this particular ridge into two halves if you observe, right? And if you see this image, this is from Thingvellir National Park. So this Thingvellir National Park, if you go, this is a hot spot of tourism and popular destination for many tourists, and also it is very famous for movie shoots and many famous series like Game of Thrones and others. So they have been shot on this particular line if you observe in Iceland as well. So these are the areas which are famous, which are to be remembered as particular locations, part of the Atlantic Ridge or the mid-oceanic ridge that we study under ocean bottom relief or ocean bottom topography of Atlantic Ocean. Then let's elaborate on the ocean basins. Now remember, basins are the particular locations or zones of the same Atlantic Ocean which are having their unique characteristic in terms of their depth, in terms of their width, largely in terms of their shallowness if you see. So there are 6 different basins. So what are those? First is called Labrador Basin. So remember, this is Labrador Sea. So this particular basin is called Labrador Basin, right? And it is situated where? Remember, continental shelf of Greenland in the north and Newfoundland Rise in the south. So this is what we observe as the Labrador Basin, and average depth is about 4,000 meters. So this is important to remember. Then you have Northeast Atlantic Basin. So northeast is this particular basin if you observe, right? So this is important to remember. The depth here is about 5,000 meters. Then you have Northwestern Atlantic, which is perhaps the biggest basin in Northern Atlantic, right? So this is what you observe as the northwest part, right? And its depth again is about 5,000 meters. Then you have Cape Verde Basin, and Cape Verde Basin is situated between Central Ridge and Africa. Now remember, Central Ridge and Africa, which is located here in this particular portion if you observe. So this is the Central Ridge and this is Africa. In between you have a Cape Verde Basin, which is basically between 5,000 to 7,000 meters deep. This is its description. Then you have Guinea Basin. So Guinea Basin is along Guinea coast, Africa. That is important. So this is particular coast. If you see, this is Guinea Plain, this is Guinea Basin, right? And then what you have here is that Brazilian Basin. The name itself suggests that this is close to Brazil. So this particular place is called Brazilian Basin. So largely what you observe is that we have here 6 basins in the Atlantic Ocean, and all these 6 basins you can name on the map. You can observe here that where are they located, what is the particular area where they can be found, right? And what are their particular characteristics. So that is important to remember in terms of ocean basins, also their average depth values. So the Atlantic floor is characterized by general absence of a linear deeps. Now remember, linear deeps or straight deeps that we say are not available. This is due to the absence of rather recent fold lines along the Atlantic coast. So you don't have many fold lines along Atlantic coast. That's why you don't have many linear deeps. But there are many deep trenches that we already know, deep sea trenches or troughs that are available, found on the ocean floor, namely Puerto Rico, the deepest one, and then you have the central part, which is the Romanche Trench, as we have already learned. And Puerto Rico, there is a very deep trough, and it's also called Puerto Rico Deep, remember? And in fathoms, if you observe, it is 4,812 fathoms. And remember, what is 1 fathom? 1 fathom is how much? 1.8288 meters. So if you want to convert, you can convert, and it will come about 8,300. So this is what the depth of this Puerto Rico Trench is, and Romance Trench, as we remember, it is about 7700 to 7800 meters deep. So these are the two deeps that are available here. And remember, Romance Trench, this deep also divides the north and south ridge into two parts. So now, when we have discussed in details the bottom relief and other parts of the topography of Atlantic Ocean, in the sessions to come, we'll be talking more on Pacific Ocean and Indian Ocean as well. So stay tuned, stay safe, all the best wishes.